Children, today let us learn how to write the electronic configuration. So, what is electronic configuration? Before knowing to write the electronic configuration, first let us try to know the basic structure of an atom. An atom contains three fundamental particles, as you know. First one is the proton, and then the electrons, then neutrons. So, these are said to be the fundamental particles of an atom. So, how these particles have been arranged in an atom? If you take an atom, as you know, an atom contains a central part which is called the nucleus. Within the nucleus, the protons and neutrons are found. Around the nucleus, in definite circular orbits, the electrons are revolving around. So, that you have studied, right? So, here, these are the circular orbits where the electrons are found. Okay? Protons, these are the positively charged particles. Neutrons, they don't have any charge, whereas the electrons, they have negative charge. The number of protons in an atom is equal to the number of electrons. We call that one as the atomic number. Atomic number, which is indicated by the letter Z, that you know. Atomic number, it is nothing but the number of protons or electrons found in the atom. So, then what do you mean by this electronic configuration? So, these electrons are arranged in a definite fashion or in a definite pattern. So, let us see how the electrons are arranged. These circular orbits are called energy levels, or they are otherwise called shells. There are different types of energy levels, or the energy levels are named with K, L, M and then N. So, these are the different names that has been given to the energy levels, which are called K shell, L shell, M shell and then N shell. Okay. Now, if you take any shell, there will be maximum number of electrons which get accommodated in a particular shell. The maximum number of electrons in a shell is given by the equation 2n square. So, this is the formula to find out the maximum number of electrons in a particular shell. So, now the value for different, the n value for different shells is given by, for K, the value of n is 1, and then for L, the value of n is 2, and then for M shell, the value of n is equal to 3, and then for N shell, the value of n is equal to 4. So, like this, there is a definite value of n for different shells. Now, if you want to find out the maximum number of electrons in a shell, so it is given by, now for K shell, what is the number of electrons present in K shell? Now, what is the value of n? It is 1. So, 1 square, that is 2 into 1, 2. So, now it is 2 into, what is the value of n square? N, it is 2. So, that is 2 into 4, that is 8. Now, for N shell, M shell I mean, it is the value of n is equal to 3, it is 3 square, 3 into 9, it is 18. So, now the value of, or the number of electrons present in N shell, it is given by 2 into the value of n is equal to 4. So, here 4 square, that is 16 into 2, that is 32. Okay. So, this is how we will find, or we can say, the maximum number of electrons present in different shells. I think you can understand this one. If you take K shell, there will be 2 electrons to the maximum, and then if you take L shell, the maximum electrons that can present in L shell is 8, and then if you take M, the maximum number of electrons is 18, and then if you take N, the maximum number of electrons is 32. In addition to the shells or energy levels, there are small rooms or compartments within the shells which are called subshells. Subshells. They are also called orbitals. Subshells or orbitals. There are 4 different types of subshells, so which are called S, P, D and then F. S, P, D, F. So these are called the subshells, remember. As there will be maximum number of electrons in K, L, M and N shell, similarly here also in these subshells there will be maximum number of electrons. If you take S subshell or S orbital, the maximum number of electrons in S orbital is 2. And then come to P, the maximum number of electrons that P can accommodate is 6. And if you come to the D orbital, the maximum number of electrons will be 10, and if you come to the last one, that is F shell or F subshell or orbital, so it can accommodate 14 electrons. So this is the most basic thing that you have to know to write the electronic configuration. Hope you can understand now. Okay, there are shells or energy levels. Okay, within that there are subshells. Subshells can have maximum number of electrons, so to their capacity that they can accommodate. Okay, now come to K shell. K shell will have only one subshell, that is S, right? And then if you come to L shell or energy level L, it will be having 2 subshells, that is SP, right? Then so come to the third energy level or M shell. It can have 3 subshells SPD. Okay. Now if you come to the fourth shell or energy level, it will be having 4 subshells, that is SP, D and then F. Okay. Each shell will have the subshells where the electrons get filled up. So now let us come to the main topic here, electronic configuration. What is this electronic configuration? So electronic configuration is nothing but the way or the pattern how the electrons are get filled up in the shells and then subshells. Actually, so this follow a rule or a principle which is called Aufbau principle that you are going to study in your higher class. So here the electrons are get filled up in the increasing order of their energy levels. See, the energy level of K shell, it is lower. I mean, it is having the minimum energy level. And then come to the L shell, so it is having the higher energy level. And then if you come to the M shell, it is still higher. And then if you come to the N shell, it will be having higher energy level. Okay. So here, following this Aufbau principle, the electrons, they get filled up in the increasing order of their energy levels. So how they are going to get to be filled in the increasing order of their energy levels, that we can see now. Now see, so this is the pattern how the electrons are get filled up in the increasing order of their energy levels. First see here, the electrons get filled up in 1s, after that one it goes to 2s, and then 2p, 3s, then it is followed by 3p, after that it is 4s, 3d, 4p, 5s, 4d, 5p, 6s, and then it goes to the f orbital, 4f, 5d, 6p, 7s. So like this it follows. That means, see, it goes, the electrons, they get filled or they get occupied according to the increasing order of their energy levels. So this what we call the electronic configuration. Hope you can understand. So now let us take an example. See here. So I have taken 3 elements, okay? Oxygen, sodium and silicon. Now oxygen. What is the atomic number of oxygen? It is 8. Now, the atomic number 8 means there are 8 electrons. How these 8 electrons have been filled in different shells and subshells, that we know. That we shall know now. Okay? Now, I have to write the electronic configuration of oxygen, let us say. Right? So now, come to the first shell. Okay? First shell means that is K shell. Here we are having the subshell, yes, it is 1s. What is the maximum number of electrons that present in the first shell? That is 2. It is 1s2. It is over. Now it comes to the second shell, that is L shell. There are 2 orbitals, okay, S and then P. So now the second shell here, 2s, okay. If you come to 2s or s, this is the maximum number of electrons in s is, it is 2. Now where it has to go? It has to go to the next orbital, that is p orbital, that is 2p. See here, now 4 electrons are filled up. The maximum number of electrons or the atomic number is 8. Now the rest 4, where it has to go? Now p can have 6 electrons. So therefore already 4 has been present here. The rest of the 4 electrons are occupied by, so this orbital. Okay. So now this is the electronic configuration of oxygen. So that is 1s2, 2s2, 2p4. Okay. Now come to this one, sodium. The atomic number is 11. Shall we write the electronic configuration for this one? Yes, come on. It is 1s2, right? Where it has to go now? 2s. 2s means it is 2s2. Now it is, next one is 2p. Now it is 4. P can have 6 electrons. 2p6, 10 over. Now 1 electron is left. So this 1 electron goes to the third shell, that is 3s1. Okay. So this is the electronic configuration of sodium. Right. Now come to silicon. Right. The atomic number of silicon is 14. Right. So now it is once again 1s2, 2s2, then 2p6, 10 over, then 3s2. Okay. Now 2, 4, 4 plus 6, 10, 10 plus 2, 12, 2 electrons are left. Where it has to go? 3s. Next one is 3p. Okay. So here 3p, of course, it can have 6 electrons, but 2 electrons are left behind. We have enough space here. Therefore, so the remaining 2 electrons, it will go to p orbital. Okay. So this is the electronic configuration of silicon. So let me take one more example, that is calcium. Calcium, Ca. The atomic number of calcium is 20. Right? Now I have to write the electronic configuration for this one. Now it is as usual 1s2, okay, 2s2. Next electron goes to 2p, 2p6. Now it goes to 3s2, 3p6. Now count the electrons. It is 4, 6, 10, 10 plus 2, 12, 12 plus 6, it is 18. 2 electrons are left. Now where it goes? Will it go to 3D? No. Even though it is in the third shell, remember, d orbital, okay, it is very big one. The energy of d orbital is very, actually it is very more or much more than that of the next orbital, that is s. Therefore, after getting filled up in the p orbital, the electrons never go to d orbital. Instead of that, it goes to the s orbital. Now, the rest of the electrons, they move to this one. Okay. So, if you write the 3D here, 3D2, it is wrong, because after getting filled up in the third orbital, they never go to the d orbital, because d orbital is a very big one which is having a high energy. So, therefore, it has to follow the Aufbau principle. So, therefore, following the Aufbau principle, the electrons get filled up in the next higher energy. So, that is the s orbital. Okay. So, this is how we have to write the electronic configuration of the different elements. So, let us try to write the electronic configuration of some more elements. Okay. Right.